Ryan is investigating whether the students in a sixth form college believe that their mathematics classes are satisfactory. He has an alphabetical list of all 369 students taking mathematics saved on a spreadsheet. He decides to select a sample of 40 students and considers two different sampling procedures. Procedure A, assign a distinct random number to each student. Select the 40 students with the smallest random numbers. Procedure B, generate one two-digit random number. Use this random number to select the starting point on the list according to the rule shown in the table below. Select the student identified by this rule and then select every ninth student on the list after this, stopping when a sample of 40 has been obtained. Explain why procedure A will generate a simple random sample. Identify two features of procedure B that prevent it from generating a simple random sample, and describe how you can generate a random sample size of 40 from 369 students using what's known as systematic sampling. Okay, so let's consider case A. Assign a distinct random number to each student. Select the 40 students with the smallest random numbers. So let's just look at this using this spreadsheet. So here we have a spreadsheet, the position number on the list, been sorted alphabetically, the surname and the name. Okay, and we can see that we actually have, if we go right down to the bottom, 369 students. Okay, all these names have been randomly generated as well. They don't actually represent anybody that I know. Okay, so in here we'll put a random number. So we put equals rand. Okay, and you have to put two brackets in, close the bracket, put a random number, and we'll just copy that all the way down to 369. So it's all actually doing what Ryan's actually done here. Okay, there we go, got a set of random numbers. And then what we're going to do is we're going to reorder the list. So we're going to select those names like that. Make sure we've got every person in the list. Okay, and we're going to go to data. We are going to go to home, and then we're going to go to sort here. I'm using a Mac, and we're going to do a custom sort, and I want to sort on the random number. Okay, we press OK, and then we get our random sample by taking the 50th. So we go to 1 to 40, sorry, we're taking 40, so up to prints, all these will be in my sample. Okay, so that's how we do that with a random number. So we need to answer that question. So, as a distinct random number is being assigned to every student, each possible group of the students of size n is equal to 40 has the same chance of being picked. Okay, so therefore we have a simple random sample. Procedure B, generate one two-digit random number. Use this random number to select the starting point on the list according to the rule shown in the table below. Select the student identified by this rule, and then select every ninth student on the list after this, stopping when a sample 40 has been obtained. If we now go to our list, and I'll put it back in alphabetical order, so we just need a random number, so we don't need this last column here, so we'll just go over here and we'll generate a random number between 0 and 99. So we'll put equal random. We need the one at random in between. Okay, and we want it to go from 0 to 99, because that's what's in that table. And we get the number 41. We're going to look at the first 6 names on 41. let's just go back and quick look at the table. So the table 41 would be the third person on this list, according to this. And then if we go to the third person on the list, this is going to be Milo, according to my list, okay, and then we're going to take every ninth person from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go to that one, and then we so on to select the next ninth person. That's how that works. Okay, what is the problem with this for a simple random sample? Well, say we, for example, as had the starting point of number 6, okay, but we had the third person, but we still started with the 6th person on the list. Hence, we would stop on once we've done this. We've got the 6th person, then there are 39 more people to be selected. They're 9 apart, so that will take me to the 357th person to be on the list, which will mean that the last 369 minus 357 is equal to 12 students not being selected. If I take my example, which is I was selecting the third person, so it's third person plus 9 times 39, and then if we select that, take that away from 369, that will mean in my case, 15 students would not be being considered, okay? Obviously, this is going to get worse if I select any of these 1 to 5, okay? So in the case of mine, when I selected the third person, 15 students are not going to be selected. So this is not a simple random sample. That's one possibility. Another possibility, if we look at the random numbers in this table, so we've got from 0 to 10, 11 to 30, that they don't all have the same probability of being selected. So that's another possibility that's wrong. And as we want a simple random sample, it's also not possible to select some possible samples. For example, we can't select the first 40 on the list. It's just not possible. Okay, so there's 3 reasons. You only had to actually give 2 for this this question. Okay, for the last part, describe how you could generate a random sample of 40 from the 369 students using systematic sampling. Okay, so to do that, we need to randomly select a starting point on the list between 1 to 18. And the important thing is that it's random, that each of these 1 to 18 has an equal chance of being selected. And then select every 9th student on the list after this. Okay. Note 18, if we did 18, take the 18th person, we're going to take the 18th person plus 9 times 300 times 39. So there's 9 apart and there's 39 left. Once you've selected the first one, we'll give 369, which is the total population size. Okay, so this is an example of systematic sampling. Okay, so this has been a video to look at different procedures for sampling. I hope you've understood, and I thank you very much for watching.